Welcome back, Math 3380 students. This is the last topic that I want to check in with you on, and this has to do with multiplication. We're going to take a look at how things work in base 10 and then try and help bridge the gap for how that means it would work in base 60. So if I'm working in the Babylonian system. Now, what happened for a lot of you is in trying to do a Babylonian multiplication problem, you decided you could jump out of the Babylonian world into the Hindu-Arabic world, do all your work there, and then transfer it all back into the world of the Babylonians. Well, you know, if you're Babylonian, you have to stay in Babylonia. And so we're going to take a look at how we can use that multiplication table. There's a reason why we put it together. So stay tuned as we sort of walk you through a couple of important aspects so that you can multiply like a Babylonian too. The first thing I want to talk about is just thinking about how base 10 works and in comparison to what would happen in base 60. So for example, we know in base 10 that if I were to take 7 times 10, that would give me the product of 70. So in fact, when I multiply by the base, which in our system is a 10, the result, if this is in the ones place and I multiply it by 10, it ends up over here in the tens place. So it got shifted one full place value because it's based in 10. And we know, going on from there, if I were to say 7 times 100, you would tell me that that was 700. So again, because I am multiplying by 10 and then again by 10, my 7 that was in the ones place is now being multiplied into the hundreds place. And so that's kind of a nice way that things move along. And taking advantage of those powers of 10 is something that we really like to do. Now, what would be the analogous situation over here in base 60? So if I had 7 and I wanted to multiply it by something that would shift it one place value to the left, well, we might think, well, you can multiply by 60, but the way that we record 60 in our new system is to record it as 1, 0, right? Now that looks very much like the 10 that we just wrote down over here in base 10. And so there's something sort of interesting to think about there. So when we look at this, this is also the base, but we're working in a base 60 system. So when we think about what the product should be and how that is going to play out, we can see that that's basically just going to shift the 7, which is now sitting in the ones place. If we're going to multiply it by something in the 60th place, then that's going to end up giving us the result of 7, 0. Now, if I were to then take something like 7, 0 and multiply it by a 1, 0, let's think about what that would do. Because again, what I want to do is to notice that this is the base. So I'm multiplying this thing by a group of 60 by the base. That means everything should shift a place value to the left. So in fact, that I can kind of see how that works because this is in the 60s place and this is also in the 60s place. And when I multiply something in the 60s place times something in the 60s place, I've created something that's in the 60 squareds place. That would be the third place over there. So when I think about multiplying that, then even though I'm taking advantage of some basics here, this now I can write down without doing any work. I know that this is going to be 7, but it's going to have to be over here in the 3600s place. Because again, remember when we're working in base 60, here are my 1s, here are my 60s, and then here are my 60 squareds. So let's keep that in mind as we're thinking about our multiplication, and we'll start by, again, looking at an example from base 10, seeing how that helps us translate into base 60. So as I noted, let's start with a Hindu-Arabic multiplication situation or problem. And we'll take one that's really straightforward. If we needed to do something for multiplication, if we needed to take 6, let's say, times 38 in our system, one of the easy ways that we can see how our algorithm works is we can think of this as 6 multiplied to the 38, and we can think about that 38 as its place value parts, right? So again, thinking about it that way, I know that I've got tens and I know that I've got ones. And so I'm sort of looking at finding those partial products using the good old distributive property, right? So if I'm working in base 10, then I'm just simply going to take 6 times 30, and I'm going to add to it 6 times 8. Again, those are my partial products. And when I do that multiplication, I can see that 6 times 3 is 18, so multiplying it times 10 would be 180 plus, and then I've got 6 times 8, which is 48. And then in base 10, all I need to do is to put those together, knowing that I'm going to have to do some trading or regrouping, right? So if I wrote this vertically for a second, we can see as we put these together that we're going to have to do some trading and regrouping here. So this is 12, and we're going to need to trade a group over to the hundreds place. So it'd be 228. So even though I have these partial products, when I go to put them together, I'm going to have to remember that I can't have more than 10. I'm going to have to do some trading and regrouping. Now, these are all pieces and parts to being able to do Babylonian multiplication. So let's see if we can try and translate what we've just been talking about in our first couple of slides to what's going to happen in the Babylonian setting. Well, let's take the same product. Let's take 6 times 38. But let's work within the Babylonian scope of things. So we're not looking for groups of 10 or 100 and so forth. We're going to be looking for groups of 60 and 60 squared. But we want to do this efficiently. So just like we learn our normal multiplication tables, we're going to need our Babylonian multiplication tables. But the idea is going to work exactly the same. I can still think about breaking apart my 38 as 30 plus 8. And that still does mean, according to the distributive property, that I'm going to have 6 times 30 plus 6 times 8. Now here's where I'm going to go to my Babylonian multiplication table. So I'm going to take a look in my table for the row 6 to intersect with the column 30 and see what's in that column. And what we find is that when we look at that column, that is recorded as 30 when we're working in base 60. So again, remember, we're not putting things in groups of 10, we're putting things in groups of 6. And so a minute ago we said that was 180 when we were thinking in base 10. And certainly when we think in groups of 6, that would be 3 groups of 60, and there we go. Now, what about this other part, 6 times 8? Well, 6 times 8 is still 48. I don't need to do anything fancy or crazy with that because 48 is legal in terms of my ones position. And just like I talked about setting this up vertically in the other column, what we want to do is to put these two things together. Well, here in this place, we can have 48 because it's base 60. We're not in trouble until we get to 60. We can have 59. In this case, we got 48, and then we're going to have 3. So the answer to my multiplication problem is just going to be 3, 48. So using my Babylonian multiplication table, I'm not doing anything out into the Hindu-Arabic world and then bringing it back. I'm using what I read from the table, putting those partial products together, still using that good old distributive property to make sure that things are working. Okay, so let's take something a little more complicated. In other words, let's have a couple of digits or a couple of place values in our Babylonian first factor. So I'm going to remind myself that these are sitting in the ones position and these are sitting in the 60s position. Okay? So this is going back to that first conversation that we had here. And we also want to keep track of the fact that we're doing that same sort of distributive thing. So I can do this sort of in pieces and parts and sort of think about how this is all going to play together in terms of what's there. Now, if I start with the simple part, if I have the 52 and I need to multiply it by 7, then what I can do here is, again, think of that 52 as 50 plus 2, and then I need to multiply that by the 7. Now, because this is all in the ones place, I'm going to be able to just read this directly from the Babylonian multiplication table. So when I take 7 times 2 and 7 times 50, I'm going to be able to just read those from the body of the table and sort of put them into place. So when I go and I look for 7 times 50, that turns out to be 5, 50. And when I take 7 times 2, that becomes 14. So both of those are in correct position, and I know that I'm ready to then put those together to find my final answer. Now I've got to be a little bit more careful with what I'm doing over here when I take the 7 and I'm multiplying it to the 13, because it's really not a 13, it's really a 13 that's sitting in the 60s place. So I kind of want to remember that I've got this sort of additional place, that this time I'm not taking ones times ones, I'm taking ones. This is in the ones place, and this is in the 60s place. So whatever I get has to end up over here in the 60s place. So I'm still going to think of this 13. I'm still going to think of this 13 as 10 plus 3, but I'm going to remember it's sitting over here sort of in the 60s place. So when I multiply by 7, I'm sort of going to pick up some additional an additional place, right? So when I multiply that to that, that's going to be that, but then I'm going to have to, again, sort of do my reading from my table. I know that my 7 times 3 will give me 21, and I know that when I do my 7 times 10, that's going to be a 1, 10. And I'm going to have to add those together, right? So those are what I get from the 7 times 10 plus 3, but I'm remembering that it's sort of one place over from what I was originally thinking with my 52. So if I think about this, I can combine these and it becomes 1, 31, but then there's another place there that being ones times 60s, I know this has to come over into the 60s place. Then I'm going to add to that my 5, 50 and my 14. So let's copy that over into the next page in a vertical form, and we'll take a look at how we put all of that together.